All right, guys, today we're going to talk about lesson 78, which is solving quadratic equations. We've done this before. This time we're going to solve by factoring. It's going to be a special type of factoring though. So we're going to quickly review the difference of two squares. It's if you have a term squared minus another term squared, it will always factor to be a plus b, a minus b. So we're going to look at an example like that. If you have 9x squared minus 25, both 9 and 25 are perfect squares, so we can rewrite that as a 3x plus 5 and a 3x minus 5. Since it's set equal to 0 and our directions are to solve, we need to set each piece equal to 0 and solve from there. So here's our two pieces. In this equation, we need to subtract 5 from both sides, and then we'll divide by 3. Over here, we're going to add 5 and divide by 3, giving us two roots or two solutions, two x-intercepts, whatever you want to call them. So x equals negative 5/3 and x also equals positive 5/3. Here is another example. This time we have 7x squared equal to 63. So in order to factor, we need to move that constant over to the left by subtracting. Neither of our constants here, our leading coefficient or our constant, are perfect squares, but you can factor out a 7. When you factor out a 7, it leaves you with a difference of two squares. So now we can factor that x squared minus 9 into an x plus 3 and an x minus 3. You get our roots from here. We would get x equals negative 3, and here is x equals positive 3. This one's a little different. We have 10x cubed minus 10x, so not a difference of two squares to begin with, but we can factor out a 10x from each term. When we do that, we get a 10x and then x squared minus 1 left in parentheses. And x squared minus 1 is a perfect square factored to be x plus 1, x minus 1. This time we have three roots. We have x equals 0 from this first piece, x equals negative 1, and x equals positive 1. Couple more examples. X to the fourth minus 16 here. This actually is a difference of two squares. So, excuse me. Square root of x to the fourth is x squared. And obviously 16 is a perfect square. So this becomes x squared plus 4, x squared minus 4. X squared minus 4 is another difference of two squares that can be factored to x plus 2, x minus 2. Now here's where we're going to get our root. So we need to take this piece and set it equal to 0, and these two are pretty obvious ones. But this x squared plus 4, when we set that equal to 0, subtract 4, take your square root of both sides. Now we know how to solve this. We have imaginary numbers, so we can give an imaginary root. So our x would be equal to plus or minus 2i, which is a square root of negative 4. And then we have x equals negative 2 and x equals positive 2 from above. So we still have four roots, just two of them happen to be imaginary and two of them are real. We have four roots because this is a quartic function. It has a degree of 4 or a fourth power to begin with. One more example. It looks a little more complicated. Here we have 9x squared minus 12x plus 4 minus a trinomial x squared plus 10x plus 25. So we want to factor each of these. This first trinomial will factor to be a 3x minus 2 squared, and then this piece is x plus 5 squared. So now we have another difference of two squares. This 3x minus 2 happens to be our a value, and x plus 5 happens to be our b value. So in our very first the very first part of the video, we had a squared minus b squared factors to be a plus b, a minus b. So we're going to take and factor this into that. So remember, 3x minus 2 is a. So we have a plus our b, which is x plus 5. So a plus b, and then our second set of parentheses, they happen to be brackets in this problem, is a minus b. Inside each of these brackets, we can do some simplification. So we would have a 3x plus another x, which would give us 4x. Negative 2 plus 5 would give us a positive 3. Over here, we have a 3x minus x, which is going to be a 2x. And a negative 2 minus 5 would be a minus 7. So here, what I just verbalized was 4x plus 3, 2x minus 7. Now we can get our two roots by setting each of those pieces equal to 0. So this root would be a negative 3/4. And this is a 7/2. And that is all for today.